Good afternoon, everyone. I hope everyone is doing okay. This afternoon we will be presenting on the ellipse. My group members are Ms. Jaya Siratan and Ms. Premati Puran. Now, on ellipse, our presentation would include the following information on ellipse. First of all, what is an ellipse? The parts of an ellipse, perimeter, as well as area of ellipse equation and relations and graphing an ellipse. It also includes some examples as to how to graph the ellipse and some simple calculations. So I'll now hand you over to Ms. Jaya.
Good afternoon, everyone. So, what is an ellipse? An ellipse is a closed curve where all the points add up to the same total distance from two special points called the foci. I hope I pronounced that correct, or in other words, we call it the focus. So, some example of ellipse in our everyday life is the shape of a running track, that here the diagram there, a oval mirror, and the path of planets around the sun is almost an ellipse too. So if we see there, an ellipse is like an egg shape, a oval. Next slide, please. So we have here the parts of an ellipse. So before we could do any other thing, we must know the parts of the ellipse. So when the ellipse this is said to be horizontal. So our two focus is on the X, and that's there is our major axis. It have the longest diameter. If you could see there, good. We have our minor axis, which is the Y axis here. It have the shortest diameter. The co-vertex is the end of the minor axis, as we could see here, these 2 points here. The vertex is the end point of the major axis, as we could see here. And our two main point, which is the focus or the foci, if I'm pronouncing it correct, is here. Good, and we know the center of this ellipse is there. Next slide, please. So here we have an example of a horizontal ellipse and a vertical. So you see on the horizontal ellipse, the major axis is along the X. And when it is vertical, the major axis is along the Y. Next slide, please.
Could somebody erase here all this? Yeah.
Yes, sir.
And don't be afraid of the pronunciation of the plural of focus. Some people say foci, some people say foci, right?
Sir, I don't know the correct one.
Yeah, when you listen to the videos on the internet, you hear people say foci or foci. Nothing wrong with that.
Okay. So here we have the perimeter of an ellipse. So as you can see, here is the formula to find the perimeter, where A is the semi-major axis and B is the semi-minor axis. And we use pi as 3.141, which is the same as 22 upon 7. So here we have an example of finding the area of an ellipse. So here A is 3 cm and B is 2 cm. So the formula is 2 pi the root of A square plus B square all divided by 2. So in the formula we replace A and B with our values. Then we calculate. So when we calculate, our perimeter is 15.7 cm. I will now hand you over to my next colleague to continue with the area of an ellipse.
We could clear the writing on here. Yes. So the perimeter, as Miss did just now, we are using a formula. So with the area of the ellipse, we have our major axis and our minor axis. A being our major axis, which is here, and axis and B. Now the formula that we're using is pi AB. So this simply means multiplication. The order in which you do your work and it doesn't matter. But once you're using the same formula here. Now we can either use pi as the decimal, divided by the decimal one, which is 3.142, or 22 over 7, whichever one you're comfortable with. So we go A, they give us that A in this case would be 3 cm and B 5 cm. We go 3 cm times 5 times 3.142 and we work come down. This square here represents that we're doing area. It might seem simple, but when we leave this out, there would be something wrong with our question there. Now, Miss made mention of the horizontal ellipse as well as the vertical ellipse. This is another example of it, as well as to the bottom here is a simple formula that we use to find that we use when we are given the horizontal ellipse, and for the vertical one, this is the formula at the bottom that we use. Notice that there is a difference with the two. At first glance, it might seem same, but there's a difference. So our A square is at the bottom here, and our B square is here. So that's just a slight difference there. Now, how to graph an ellipse? We can use the same formula that was given earlier, and we have this example here. Now, we have a video that gives us a little bit of an example using decimals. So we were given the equation up here, and so we substitute, just randomly substitute some values. R equal 1, H equal 2.21, and when we change those values now, it shows us here how is it our ellipse can change its shape. Let me play it back one more time. Not only change the shape, change position on our graph. So moving on to our ellipse equation. So to get to this equation here, which is the standard equation that we're going to use to find the ellipse, to get to that, we had to do a bit of working. So we have the root of x plus c squared plus y squared plus the root of x minus c all squared plus y squared equals to 2a. And when we work this down and simplify it, that is how we ended up with this ellipse equation here. And as I mentioned before, the horizontal and the vertical, they basically have the same equation. Only the values at the bottom here are a bit different. So now I'll hand you over to Miss Puran and she will take you through the next few slides.
Good afternoon, everyone. My task is to present on the conic section and some other slides. So first, we need to know what a conic section is. So a conic section is formed by slicing a cone at an angle smaller than that of the side. So as you can see here, it's been sliced at an angle and it's not been sliced like this. Okay, so next slide, please. All right, so the eccentricity of an ellipse, pardon me if I'm not saying that correctly. The eccentricity of an ellipse is a number that tells how stretched the ellipse is. It compares the distance from any point on the ellipse to its focus and to its directrix. So you can see it over, let me get this. So how stretched it is from the focus, from this point here, to the directrix. So it's here. Okay. Next slide, please. All right, so Miss Cheyenne will be doing example 1 and I'll take you through the other examples.
Okay, so this is an example here of the finding the ellipse when they give you the major axis. Now, they give us the equation here and they ask us to find center ABC, vertices, foci, eccentricity, and area. So we have a number of things to find here. Now, they give you based on your formula that a squared is equal to 25, b squared is equal to 9. So by them giving you that, you know your values of a and b. Now, since A is less than B, the major axis is going to be horizontal. Therefore, these would be your vertices here. The first one would be the plus or minus A and the other point 0, right? Or the next vertice would be 0 and plus and minus of B. Well, we know A would be 5 and B would be 3. That is how we get the 5 and 3 based on the information that they give us. Now we know A, we know B, but we need to find C. We are given the values, we use Pythagoras theorem. We are given our A value and our B value, square terms here. 25 plus 9 gives you 16, square root of 16 gives you 4. So now we have A, B, C. We have a vertices. Next thing that we have to find would be the phi. Now, because they give you C, and we use this format here, plus or minus C, and the next number would be 0. And since we just found C, that would be our foci, which would be 4, plus or minus 4, 0. So we have the next item that we have to find would be the eccentricity. And eccentricity is equal to C over A. In this case, we know C is 4 and we know A is 5. That is how we have 4 over 5. You can leave it as a fraction or you could write it as a decimal. And the last thing that we have to find would be the area. Now, in previous slides, we talked about the formula for finding the area of an ellipse, which would be pi AB. Pi is 3.142 We know A is 5 and B is 3. Now you could leave your answer like this, or you could simplify it further, being 15 times 3.142, and you work it out. This is the diagram here that goes with the ellipse. Now this would be this first point here, plus or minus 5, 0 would be here, or if we have negative 5, it would be over here. Over here would be positive 5. If, say, we're using this vortex here, 0, 3, positive 3, that is, it will be up here. And if it's negative 3, to the bottom here. Ms. Puran will now take you through the next example.
All right, so I'll be looking at example 2. All right, so the ellipse with center 2, negative 1, it's a horizontal major axis. So the equation we're given is x minus 2 all squared divided by 16 plus y plus 1 all square over 4 is equal to 1. So we have to find the center, the vertices, the foci, and eccentricity. So the center, by looking at the terms in the parentheses, we know that we find the center at 2 minus 1. And since the larger denominator here is 16, we know that it's a horizontal ellipse. All right, so we have to calculate the semi-major axis, which will be this. So a squared is equal to 16. So that will give us a equal to 4, which is here. So b squared is equal to 4, which will give us b equal 2. So the semi-minor axis now, we have 4 and 2. So we know the vertices are here. So we have, sorry, 1 second. So we have h plus or minus a and k. Then we have 2, which is h plus or minus 4 and minus 1. So minus 2 minus 1 and 6 minus 1. So you can see that over in the diagram over here. So we have 6, negative 1. Then we have 2 and 1. So the co-vertices now that we have to find, we have 2 minus 1 plus or minus 2, 2, 1, and 2 and negative 3. So we have to, these are the main points that we have to look at. So moving on, we have c squared is equal to a squared minus b squared. So c squared, we know that a squared is 16, and we know that b squared is 4. So c squared is equal to 12. 16 minus 4 is 12. C is equal to the square root of 12, which will give us the 2 square root 3. So, or if we have to calculate it all, or do the calculation, we end up with 3.46. So to calculate the foci now, we have h plus or minus c and k. So 2 plus or minus 2, the root of 3 minus 1. Then we have 2 plus or minus, when we did the calculation, we established that this is the number that we would have, and you have negative 1. So calculating the eccentricity now, we use our formula, c over a, and then when we calculate, we have root of 3 divided by 2, or yes, root of 3 divided by 4, or this. Erase it. Okay, so next slide, Michelle. Hmm. Mhm. All right, so this is example 3. So we're building an equation from the properties. So the major axis is horizontal, the center of the origin. We have A is equal to 6, C is equal to 4. So we have to write the ellipse equation first. So in this example, the process is basically reversed. We are given some specific dimensions, and we got to construct the correct equation. All right, so the initial, we have the origin, which is 0. You can see it in the graph here, which is here. And then the given values, we have A is equal to 6. Cool. Good. So we have A is equal to 6 over here. And then, which is the semi-major axis, and C is equal to 4, which is the distance to the foci. So solving for the missing variable, we substitute it in our formula. B squared is equal to A squared minus C squared. When we calculate that, we would be left with 2, the root of 5. So we have to calculate the major axis in standard form. So we use our formula that was mentioned earlier, and we will end up with 1. So x squared over 36 plus y squared over 20. So the next thing we needed to do was calculate our foci. So we have our foci, which is equal to plus or minus c, which is 0, equal to plus or minus 4, which is 0. And the other point, sorry, is 0. So the eccentricity, we used our formula, c divided by a, which is 4 divided by 6. Reduce it further, we have 2 divided by 3 in fraction form, or we can work it out to 0.6667. Okay, so that was the end of my part. Basically the end of our presentation. If there are any questions, queries, comments, please let us know.
We would just like to go over back one more thing in detail about this presentation, specifically the graphing, because it might seem a bit complicated at first, so we're just going to go over that quickly.
Could you please zoom it a bit? All right, yes, good. So as we could see here, we were given this equation here, which is x minus 2 all square over 36 plus y plus 6 all square over 16 equal to 1. And they ask us to graph the ellipse. So how do we go about doing that? So the first thing we do, we identify our x value and our y value. Our x value is negative 2 and our y value is positive 6. Good. So to find our x value, we multiply it by negative 1. That's here. So why we multiply by negative 1? We multiply by negative 1 to reflect the point across the center. So when we multiply by negative 1, the x value and the y value, we end up with x is equal to 2 and y is equal to negative 6. That gives us the center of the ellipse. Please go up, zoom it out, good. So that's here. When we graph here, this is our point, 2, negative 6. Now to find the other 4 points on the graph, we know that at the bottom here, 36, that will be a square, and 16 will be b square. So to find a, we have to equate the formula to find a only. So when we do that, we square root the 36. So a equal to 6. And then when we do it for b, 16, when we square root 16, it's equal to 4. So then we go to our center and we count from A is across the x axis. So we count from 2, we count 6 to our right. So there is where we have our point there. And then we do the same thing to our left. And we have our next point here. Then y is 4. So we go 4 upward from the center, and then we go 4 downward from the center. And then we connect the points there, and there we graph our ellipse from the equation. And I think that brings us to the end of our presentation for today. Any question from the class? Anything you're not clear on? You want us to go it over back?
All right. Let me stop the record.